Oh my goodness. Okay, what up, y'all? Yo, if you're here, you're watching this video, thank you. I'm stoked. If you're down to retake the Chapter 1 test, this is going to be perfect for you. You can make a cheat sheet off of this. I'm going to go through all the problems, every step, and then we'll see how I can help you out from there. All right. This is my first time doing this. This is it. First topic is function evaluation. So I've got a function f of x. What this is it's a function that we're calling f. The input is x. So anytime that letter x is replaced with a number, like here, f of 4, that is what I am replacing x with. Notice the x got changed for 4. So I'm going to change that x for 4 right there. I plug in a 4. 3 times 4 is 12. Minus 6 is 6, which means f of 4 equals 6. The function, when you plug in 4, the output is 6. Very cool. Same thing here. We just got like a little PEMDAS problem. It looks like the x value is 2. So I'm going to replace the x with a 2, just like that. And then I've got to do PEMDAS. So PEMDAS, P-E-M-D-A-S. Thing that comes first is parentheses. So I do inside the parentheses 2 minus 5 for negative 3. Then next is exponents. So I've got negative 3 squared. I'm going to bring it up here. Negative 3 squared is negative 3 times negative 3 for positive 9. Okay, and then working through PEMDAS multiplication. So 2 times 9. And then the last thing I've got is 18 minus 7, which is 11. So g of 2 is 11. The function of g, when I replace x with 2, the y value turns out to be 11. Oh, camera's slipping. Okay, so that is function evaluation, plugging in an input and getting an output. Solving for an input, very similar, but the other way around. What's important to notice here is that I'm asking for the value of x. So I want the input. What you are given is the output. You are given the y value. Notice that for these function evaluation ones, the x changes. The x went from x to 2, but in this one, that x is still an x. So I am not substituting for x here. I want to solve for x. So what I have is f of x equals 25, where here's my f of x, and that's equal to 25. So 25 equals the function, just like that. Cool, so that's set up perfectly. This is setting the function equal to the output of 25. Now all I've got to do is inverse operations to get x by itself. So it's being multiplied by 3, and there's this minus 5. I want to get rid of that stuff so that x is by itself. First thing is add 5 to both sides. That'll get rid of that negative 5. 30 equals 3 times x. You can probably already tell what that value of x is, but I can solve for it. X is being multiplied by 3, so I want to do the opposite and divide both sides by 3. That will leave me with just x, which in this case turns out to be 10. What that means is that the function f of x, when x is 10, that's when we have f of x equals 25. We're looking for what is the input that gives us that output. Okay, this next one, I've got a function f of x. It's this quadratic. I want to know the value of x. So I know right off the bat, I'm solving for x. I want to know what x is. When f of x is 17. So here's f of x. That's the output, and it's equal to 17. So I replace my f of x with a 17 and rewrite the rest of the function. Now I am doing inverse operations to solve for x. There's just a few more steps here. I can't get rid of this 7, this 5, this squared. Those are all like tied together. This 11 on the end, I can add 11 to both sides. And that'll cancel that out. So that's a good place to start. Then I'll have 28 equals 7 times x plus 5 squared. I've got some more stuff that I need to get rid of. I need to get rid of this 7. I need to get rid of this squared. I need to get rid of this plus 5. I don't want to square root everything to get rid of the square. That would make the 7 weird. So let me just get rid of the 7 first. It's 7 being multiplied by everything. so I'm going to divide by 7. What that gives me is 4 equals x plus 5 squared. And then here's where you want to be careful. You do not want to square x plus 5. That gives you something weird like x squared plus 10x plus 25. It's not helpful to solve for x. So instead, you can undo an exponent by using a root. So the opposite of a square is a square root. So if I square root both sides, that squared and that square root are going to cancel each other out. So I have square root of 4 equals x plus 5. Square root of 4 is the number multiplied by itself, which gives you 4. You might be thinking 2. 2 times 2 is 4. But don't forget, this is where the plus or minus comes in, because negative 2 times negative 2 also gives me 4. So that means the square root of 4 could be negative 2. I'm not sure. That's equal to x plus 5. So it could be positive. It could be negative. How I like to think of it is I split it into two realities. One where what if it's the positive 2, and one where what if it's the negative 2. So now I have two separate equations. If I solve for x in both of those equations, what do I get? I get x equals negative 3 and x equals negative 7. What that means is these are the two x values. There are two of them that when you plug it into this quadratic equation, you will get an output of 17. Very cool. There's two of them because a quadratic looks something like this. It has a mirrored aspect going on. So when we're looking for f of x equals 17, that's a y value. Say it's right around here. It makes sense that we get two answers because that will occur at two separate spots. So that's cool. Okay. Going on to page 2, we've got domain and range. Domain is possible x values. Where does the graph appear? Left to right. Range is possible y values. Where does the graph appear? Vertically, bottom to top. I put some reminders here. If it is a continuous function like these three, where they're connected lines, you use intervals, like, negative 2 to 2, or 1 to infinity, things like that. And if it is a series of dots, this is called a discrete function. You use set notation with the curly brackets, and you just list one by one what the possible x values are for domain and what the possible y values are for range. Okay, so starting off with this parabola, domain left to right, I've got these arrows. So this function is going to go forever to the left and forever to the right. So that means negative infinity to infinity would be my domain. All the way left and all the way right. For the range, I go bottom to top. I like to scan it like this from bottom to top. Bottom is right there at negative 2. And it is part of the line. There's a closed circle there, so I use a bracket. If it's an open circle, like this one over here, you use a parentheses, but this one's solid, so I use a bracket. And then bottom to top. So then going up, I got those arrows again. So that's going to go forever to the top. Negative 2 to infinity. Cool. Okay, for this one, domain left to right, I like to scan it left to right. Leftmost point, right there. That's where I first hit the function. That is at x equals negative 2. And it's an open circle, so I use a parentheses. I keep going all the way to the right, and that's where the function stops. When x is 1, it is a closed circle, so I use a bracket. Bang. Keep it moving, range bottom to top. The bottommost point is at negative 2 again for y this time. And it's open, so I got that open circle parentheses. And then the topmost point, all the way up there at y equals 3 with a closed circle, so I use a bracket. Okay, awesome. This is like a square root looking function. So I know that even though it looks like it's slowing down, it's going to keep going down and to the right. It's going to keep going down. So, and to the right. So my domain, left to right, begins when x is negative 4. And it goes on forever to the right. So my right end will be infinity. I always use parentheses for infinity. And then bottom to top, this is why I said it goes forever downwards. The bottommost point is actually negative infinity. It might look like -2, but it's going to keep going slowly down. And then my topmost point is at y equals 2. Awesome. For this guy, this is the discrete function. It's a disconnected series of points, so I use set notation with these fancy curly brackets. Domain is possible x values, so I just go one by one and I list all of the x values of these points. This point right here, the x value is -4. I have a point when x is -3. I have a point when x is -2. Nothing when x is -1. Nothing when x is 0. I have a point when x is 1, 3, and 4. Cool. Same thing for range. Now I just list the y values of the points. This point all the way down here has a y value of -4. I got nothing for -3, -2, or -1, but I do have some points when y is 0, so I add that to my list of range. I have a y value of 1, a y value of 2, and a y value of 5. Beautiful. Beautiful. Okay. Function versus not a function. The rule is that for a relationship to be a function, for every input, there can only be one output, and that input has to always lead to the same output. As soon as you have an input leading to multiple different outputs, I can't depend on that function for anything, and we say it is not a function. So for example, this table, when x is 0, y is 5. Cool. That means every time x is 0, y better be 5, or else this is worthless to me. This is not a function. When x is 1, y is 7. Okay. When x is 2, y is 9. Okay. I'll keep those in mind. Now x is 0 again, and y is 5. That's what I got before, so that's cool. X being 0 gives you y equals 5. That's seeming to function. But now I have another x equals 1, and it's giving me 8. It gave me 7 before, and now it's giving me 8. That's not good. Same thing when x is 2. It's now giving me a different value. It used to give me 9, now it gives me 11. Nah. I don't like that. Not a function. Cool. You can see a similar thing going on the graphs. We call the vertical line test. If you draw vertical lines on the graph, if it is a function, you will only ever hit one point. So I see there, that passes everywhere. There's no doubled up points. So this is a function. Yay. This one, however, this circle, I draw a vertical line. I'm hitting a point here. I'm hitting a point here. This vertical line represents one input, and look at that, it's giving me different outputs. Even though a circle is a cool shape and useful for a lot of things, it is actually not a function. Awesome. Okay, we're almost there. Function evaluation from a graph. This is similar to function evaluation in the beginning of the packet, where you're given an input and you're asked for the output. This is a function f of x, so this right here, -2, is the x value. I like to think of it like they give me the x value of the coordinate point, and I am looking for the y value of that coordinate point. So what I'm going to do is I'm going to go to x equals -2, and I'm going to look for the function when x is -2, so that point right there, y is 1. So f of -2 is 1. The output of the function when the input is -2 turned out to be y equals 1. Cool. F of 3 is when the x is 3, and it's all the way down there at -4. Bada bing. This is the other way around. Notice that the x did not get replaced, so I'm not being given an x here. I am being given the y value. So I like to think of it as they gave me the coordinate pair, and they gave me the y value, but now I want the x. So when y is 0, there's y equals -3, -2, -1. Here's y equals 0 on this horizontal line. I've got that point right there on the function. That is where y equals 0, and that happens when x is -1. Awesome. And then I'll show you how quickly you can do these, or how you can do these just by looking at the graph. F of -4. So the x is -4, right there. There's the y, 0. F of 0, the x value is 0, right here. The y value is 3. Awesome. This one's got 2 answers for x. Just like the parabolas usually have 2 answers for x, this one has 2. When f of x equals 2, when the y value is 2, I like to draw a little horizontal line where y equals 2. The x values occur right here and right here when x is -2 and when x is +1. Awesome. Okay, oh my god, we are like 15 minutes into this. Okay, we got a few minutes to go. F of g of x. This is composition of functions where you are plugging functions into each other. F of g of x. We've been talking about how when this number inside the parentheses gets replaced, that's the input. So my input here is g of x, and I'm plugging it into f. So I'm going to take f of g of x. I'm taking f of x, that's my outer function, and I'm plugging in g of x to this place right here. So I'm going to rewrite f of x, but I'm going to put a big set of parentheses so that I have a spot to safely drop my g of x. So now this is the function of f that g of x got plugged into. If I distribute that 3, I get -6x plus 9 minus 5. Combine like terms, f of g of x is -6x plus 4. Cool. This one, g of f of x. So now g is my outer function and f is what I'm plugging in. So g of f of x, I'm going to use g. I have x squared, but I'm plugging something in, so I'm going to put a big set of parentheses. Minus 2x, but I'm going to plug in f, so I'm going to leave a big set of parentheses. Plus 3. What I'm plugging into g of x is this function, f of x, 4x minus 2. I could plug it in just like that. And then now I've got some algebra to do. 4x minus 2 squared. I like to use what's called an area model. You can put 2 terms on the top and 2 terms down the bottom, and that will multiply them. So I have 4x minus 2 times 4x minus 2 for 4x minus 2 squared. What do I end up with? 16x squared. I have a minus 8x there, a minus 8x there, and a positive 4. So 4x minus 2 squared gives me 16x squared minus 16x plus 4. Then I have this minus 2 times 4x minus 2. So I will distribute the -2. That will give me minus 8x. -2 times -2 is positive 4. And then I have a plus 3 on the very end. And then from there, I combine like terms. I have 16x squared. I have a -16x and a -8x, so I combine them for -24x. And then I have a 4 plus 4 plus 3, 11. So this final answer is my function g when I plug in f of x. That one's got a lot of algebra, but it's not too bad. Let's check these guys out. These are the ones that we skipped, but they're pretty easy. I've got f of x plus g of x. All you do, here's f of x, and I add g of x. I like to put the second function in parentheses. When you're adding, you really don't need to, because there's just an invisible 1 there. So there's nothing to distribute. So this just becomes 3x minus 5 minus 2x plus 3. It's just that easy. And then I combine like terms. That would be x minus 2. So when you add the function of f to the function of g, you get x minus 2. That's it. F of x plus g of x here. Here's f of x, and then I add g of x. I need no need for parentheses since I'm just adding one g of x. And then I combine like terms. I have an x squared. I have 4x minus 2x for positive 2x. I have a minus 2 and a plus 3 for plus 1. Awesome. When you do subtraction, it gets a little bit trickier because I'm subtracting the function. You just got to make sure you put the second function in parentheses so that that subtraction, that minus, gets distributed to every term in the second function. Here's what that looks like here. I have f of x minus g of x, so I'm going to put parentheses. And then there's the function of g. I just have to make sure that this negative gets distributed to all three of those terms. So I have 4x minus 2 minus x squared. This negative is going to make that negative 2x positive, and then I have minus 3 on the end. I'll combine like terms. What do I have? A negative x squared, 6x, and a minus 5. So this is f of x minus g of x. Oh my goodness. Okay, that is everything that you'll need to know if you want to retake the Chapter 1 test, and if you'd like to prepare for the Chapter 1 stuff on the end of course. Wow, thanks for watching this. I appreciate it. I really hope that this is something that will help y'all out. And let me know if it was helpful, and I could keep doing this in the future. All right, see y'all in class.